Hi there, Serdar here for InfoWorld at IDG. Today in Smart Python, I'm going to show you a trick to speed up some kinds of Python programs tremendously, a trick called memoization. Here's a scenario. Let's say you have a function that returns a value, and when you provide the same inputs to that function, you get the same value back each time. But function calls in Python are expensive, and you want to find a way to save yourself a step since the results are predictable. Python lets you memoize functions, or decorate them in such a way that the Python runtime caches the return values of those functions for certain inputs, and just uses the cached values whenever the function is called in the future. This is done with a method in the standard library, functools.lrucache. LRU means least recently used, and I'll go into what that means later. Now here we have an example of a function that returns a predictable value for a given input. This is what's called a deterministic function. Note that there are better ways to do what I'm doing with this function. I'm just using it as an example. This function runs recursively. It calls itself, which is useful for our example since it gives us that many more values that can be cached and reused. Now when we run the function, we see there are a fair number of calls to the function's execution. We don't even need the output from Python's profiler to see that, but I can give you some example output from the profiler anyway, just so you can see that the function is being called and how many times. Now let's decorate this function with LRUcache. What this does is it caches a certain number of results from the function. By default it's 128, with the least recently used ones being expunged automatically from the cache. Notice that when we run this, the number of calls to the function drops drastically. That's because LRUcache works with the Python interpreter to intercept calls and to return a value. So you're not creating all of the overhead of a function call whenever you call a cached function. So it's faster in many respects. It's not just because the values are cached, it's because the interpreter is doing that much less work too. Now also note that we can get live statistics about the cache. The decorated function now has a cache info method that we can execute to see how many cache hits and misses have been recorded, along with how big the cache can grow and how many elements are currently in it. A couple of notes about all this. First, LRUcache only works with functions where the positional and keyword arguments for the function are hashable, because results are stored under the hood in a dictionary. So I can't pass a list as an argument, for instance, because that's unhashable, but I could pass a tuple. Another useful thing is that you can manually clear the cache if you want to. For instance, let's say I have a function that reads some value from the network, and I want to cache the use of that value for some period of time. In this example here, which I've pinched from Python's own documentation, by the way, I'm retrieving the contents of various Python enhancement proposals, or PEPs. Notice how the last few in the list, which are duplicates of ones earlier in the list, they show up almost immediately because they're cached. So after this first run, I clear the cache to get fresh results, and the way you do this is by taking the decorated function object and executing the cache clear method on it. Notice how the documents that we cached earlier, like 8 and 290, are now taking time to retrieve again, because we don't have the cache locally anymore. Now, as of Python 3.9, there's a new variant of LRUcache called simply cache. The difference is that cache is unbounded. It never expires entries. It has no limits on how many entries it holds. So it runs a little bit faster since it doesn't have to check for expiration. Now you can still use cache clear to wipe the cache, and you could also use the cache info method to check if the cache is getting unwieldy and clear it out manually. So if you want to take a little bit more direct control of how the cache works, you can use this method instead of LRUcache. That's it for this video. If you liked it, please leave a comment below. Don't forget to subscribe to the IDG Tech Talk channel on YouTube, and for more Smart Python, be sure to follow us on Facebook, YouTube, and Infoworld.com.